Welcome, the third live stream of the Flying Fox. Today we're going to try to implement physics. Maybe one of the easier things to implement. Well, a basic game like this at least. We will be using Verlet Integration. If you don't know what that means, it means we will be using an easier way of implementing the system that is more accurate than Euler integration. So to start off, I'm gonna have to really change the entire system of how we do things. Like this transform will be removed and added to the rigid body component. Since we're using classes for the components in the entity component system, it will be much easier just to add functions and everything. Although people don't like usually adding functions to components, and they are pretty detesting of it. Since C# doesn't really support structures, we will just use classes and methods in the classes themselves. Not all the time, but most of the time. So just to test if rigid bodies work, I'm quickly going to create a good old rigid body. A transform component for its position. And for now that will be it. And the old constructor to take the reference for the transform so that we can modify it within the class. And a update method that will be executed every frame. There you go. Now this is supposed to work since it is not that complicated. So I can just go here. Oh, see, I forgot to create a rigid body system which will execute the logic for all rigid bodies. Which is rigid body system. Let's see. There you go. It's using Jumbo, not ECAs. So we can just inherit from the ECA system. Now we don't have to implement everything in this class. We can just borrow it from the already created system. See here, what's your problem, Visual Studio? Oh, and that's constructor. There we go. Now I can just create a system for managing rigid bodies. Here in initialize. I see, since the last time I've made the previous live stream, I have improved the system by creating a system manager. I see I haven't implemented it here yet. So as you can see, I have a play system that's separate from all the other systems. It is a bit of a struggle. If you want to add new systems, you have to create them all individually. Where is it? Like this. It gets very tedious since you can have like 10 different systems. But now that we have a system manager, we can just use that. So let me just implement that. System manager. This is like a wrapper around the candy. And we can just initialize it up here. It's not anything specific. I don't think it needs something specific. You can just say new system manager, unless it needs the registry. No, it does not. Then I can just say system manager, add a system. What system we're going to put in? A new rigid body system. We will need that registry so we can access all the components. Did I forget something? It's possible that in this update method I will need to implement the rigid bodies. The registry. But for now, we're fine. Let's just add a rigid body, the player, new rigid body, transform. We already made that. There we go. And now, otherwise nothing's going to be updated. System manager dot update registry. Since we don't have data time yet, I can just put in 0. We're not going to use it anyway for now. Let's see. Hopefully this runs. Visual Studio isn't the fastest thing to run projects, but we will make do. And there were no errors. It is running. That means we can progress. Okay, before we continue with rigid bodies, I see I haven't cleaned this up yet. We have to see how many things we have to add just for player. And this is all in the game base class code. This is not nice. It doesn't look nice at all. So I'm just going to go back and to the player system and add all that initialized code in here. And then we have a nice and clean solution. There we go. Oh wait, it's from here. Let's copy, paste. This may give an error. Yeah, here's the new error. Okay, that is an easy fix using Microsoft XNA framework. Now we have vectors. That one error down. This does not exist. Okay, did I implement? Yeah, I did implement the texture atlas. So what you can do is, since all my components will use this central texture atlas, I will make this static. And now I can access it from anywhere in the project. So I can just say here, Flying Fox. It's Flying Fox with capitals. What is this thing called? Okay, let me just rename this, otherwise we're going to get more errors. There you go. Flying Fox dot. What's wrong? What is wrong? Private. That should be public. Right. Why is it still gone? Folks. Yes, that is correct. Oh. System manager. This should be private. This should be public. The texture atlas. So that it can be accessed from outside. There we go. Get texture. I can't remember what the position is of this texture. Let's see. Okay, I see. I didn't even add it to the assets. And that's fine. We'll just use this thing. This little cannonball. So that would be 0, 0. How big is this? It's 8 by 8 pixels. Okay. So new rectangle. 0, 0, 8, 8. Now we can just use the bump texture. And just make sure the source. Yeah. Why do I even have a source here? Let's see. Yeah, this shouldn't be here. It's not necessary at all. Just remove it. system. Just delete. And I'll just make sure this doesn't break anything. Draw. Yes. Draw texture. We don't want that. We're just gonna say no here. Why isn't the coding sense is telling me something is wrong? How can I tell easily? This doesn't highlight. There's no colors. Let's just run this and check what's wrong. Okay, what's the error? There we go. A massive error. Let's just resolve it in here. Flying fox not the error yet, but it is a concern. Okay. The transform doesn't matter. Wait, that does matter. Yeah. Just need to say this transform equals the transform we have passed. Since this we use classes, we don't need ref keywords. They are a real pain in C#. Let me see here. Okay. That is all we need. Okay. Player. All errors have been resolved. As easy as that. Now let's just see if everything draws correctly. Oh yes. Flying fox. Run. Run. Run, little game. Object reference was not set to an instance of an object. This means this hasn't been initialized. So that means we have to move it. Yes, we initialize that here. But we create this here. That's not a thing. Let us see. Okay, that would work. It's running. We need null pointers. There we go. Switch the texture, but everything is still working. It's moving. Okay. Now we can just proceed here. We don't even need a tag. Okay. Transform position. This is not really something you'd like. I just want to randomly update everything. I think if we look at this window, something you can see the bond is not rendering weirdly, if I dare say so. So this is probably because we're setting the render target each frame. But for now, we'll just ignore that. It's not the purpose of this stream. The purpose of this stream is to implement Verlet transforms or integration. Let me just see. Go here. And add a method to add a force. Just say apply force, just to sound, impressive. I know what I'm talking about. I really don't, but it doesn't matter. Vector 2, This will be the force that we want to use. No, we do not want that. We want to use Microsoft's the vector2 in the framework. There we go. Now we can implement the thing nicely. But we want the acceleration for this thing, or rather I say a resultant force. Yes, since I'm not going to implement mass, so if you know, just open this, the higher school formula for adding a force. Why is this not showing nicely? And is, let me just make this bigger, size big. That is F equals ma. If we're just going to remove this, I want to remove it because otherwise you're going to have to add a mass for every single rigid body. So if I remove this m, the force becomes equal to the acceleration. So you can either call this acceleration or force. For the purposes of this live stream and this game, I'm just going to call it force, resultant force, just to make it clear what it is. Let's say public is a vector2, resultant force. There we go. And the thing is, with Verlet integration, is you don't have to have a velocity and acceleration value for every single object. It's kind of weird to explain, but I'll see what I can do as I go along. Let's see here. There will be two position variables. This transform, just call this position. That will be the current position. Another vector2, the old position. Let me just pause frozen on there. So our velocity, vector2, velocity, since it is a vector quantity, it will be equal to the new position minus the old position. Now, just wait before you say this won't work because we haven't implemented the rest of it. But that is the basis of the entire, how can I say, the finesse of the Verlet integration is this little formula. So we just dot. You just rename this, otherwise it's going to be position dot position. Where are the components? Where is the position component? Code definition. Oh, we call it charts one. Yeah, you see. We're going to rename this position, and we are going to say this is not called position, this is called transform. And we're going to say there is a private, no, public. Since it's the decomponent system, everything needs to be able to be accessed. There will be a public, no, we want to use float values. So we have decimal points. So we will say this x is equal to position of x, and this y is equal to the position of y. Now, let us say if you are looking for the vector2 of this component, we will return a new vector, vector2 with the x and the y. And if you want to set it, we will just get a nice curly black bracket there. We want to set it. We're going to say the vector 2 you pass in. So value is the vector 2. The x is equal to the x and the y is equal to the y. There we go. Now this might break the game in another place, but we'll see later on. Rigid body system. Now we are at rigid body. Here we go. Position transform. So it's just easier to find everything. Now, if I remember correctly, this is when my memory gets a little bit fuzzy. You'll say resultant false. You need to reset it later on. So this will be the reset. And we will say, after we've done this, we will say the old position is equal to the current position. Transform. There we go. And new position is equal to the resultant force plus velocity plus resultant force times delta time squared. So delta time twice. This might seem familiar if you know your good old formulas from high school. You will look at something like position. This is terrible handwriting, but I'm doing this with a mouse. Current position or new position is equal to the velocity plus acceleration times delta t, or change in time, squared. As we already derived, f is equal to the acceleration, since we're using massless objects. So we can just rewrite this as the delta x is equal to velocity plus f times delta t squared. So here, that's our good old formula. I might have forgotten something. We'll see if we run this code. We're just going to say the resultant force plus equals this force. And just rewrite this with a small caps. There we go. Okay, now question is, where are we going to implement this? Rather than doing this, we are going to go into the rigid body system. And in here, we are going to fetch all the rigid bodies. So we get the view. What type of do we want to view? Which component? We want to view the rigid bodies. It doesn't matter if there are more components, since they will be handled by other systems. Now the view contains all the IDs, the unique identifiers of each entity that has a rigid body. So you will say for each entity E in view, we need to update it. But first we need to get the component. So rigid body RB equals registry get component rigid body, that's our type we want. This is the ID we will use to retrieve the component. Now we can just say rigid body dot update delta time, and the magic has been done. Now yes, Visual Studio says there is 0 references to this update function, but we know that we added it to the system manager class, and the system manager calls this update function when we created and added it to the system manager. So we can just go back to play system, and let's just say, see, this is ugly. Look how large it is. Just to add like a position, to add like 0.1 to the position. So just make this look clean, very clean. We want to make sure we have the actual player. So, okay, that's not necessary yet, since we only have the player in the class. So we can just say, later on you want to change this to group. Yes, because otherwise she's going to add the code in this block for every rigid body. So you want to group everything so that it is a player. A player will later on be given an input system. But for now, we're fine. Player. We will say body RB equals registry. Get component rigid body of the player. Yes. Now RB what apply force. Apply force. Just say u vector 2 0 0.1 f. We will see if this works correctly. Why is there reference? C. Now this will be updated twice. That is not good. We need to remove that. Shouldn't be a reference to it. Why did this? Let's open another window. Okay, we have too many things open. Visual Studio is unable to handle it. It's too much. It's too much. Let's see. Okay. It doesn't like that. Position. Let's dot. Why is this? Oh. So you have to update everything every single time. Position. Revamping the entire thing. That should be a title for today's video. Because we're not just creating Verlet Integration, we are revamping the entire thing. So, position, transform. Okay, that's one error. Another error, the logical error, is this. There we go. This shouldn't be here at all. Remove the player system variable, since we should put it in the system manager. So system manager dot add system, new player system, registry. What is your problem, Visual Studio? No, cannot convert from this to that. Okay, we will make you able to do it. ECS system. What's your problem? There you go. Base registry. Oh, still nagging. Doesn't like change stuff. Select done. Oh, registry. Now isn't it That's creative. That's creativity right there. Registry. We will remove that. Okay. What's your problem? Oh. Override. Ah, there we go. I think that is everything. Can we run this yet? To check if there's any other error. Now look at that. Something's definitely wrong here. It's like the entire thing is just dying. Let us see. Why? What is your problem? It's probably in here. Rigid body. Yeah, it is a logical error. Question is, which one? No, aren't I full of answers? Let me just make sure here. Integration. Google with your friend. Okay. See, yeah, we got that. Yes. What did I miss? And this is the actual body. Body system. Is it in here? No, it's not in here. What position is the new position? That's the velocity, yes. That is the acceleration, yeah. Zero transform. That should be correct. One mistaken again. Power force. Yes. Maybe I'm adding it somewhere else. Flying fox. Am I adding a position? Am I adding a force to it? No. Okay, let me just check something here. Let me just go check at my previous implementation. Probably a silly error in my logic. Source. And let's see. Okay. Aha. That is the problem. One little problem. As tiny as it can ever be. You see that little plus? Just causing us issues. That little plus. Because we want to add the new, how can I say it, velocity, the new vector, this. We want to add this to this. But I just said, no, this is equal to it. Let's see now. And there's nothing. Well, something's definitely wrong. Maybe we're doing it too quickly. Let's see. Make this 0, 0. I think it's just too fast for us. It's Flash, the fastest man alive. And we just need to call it Barry Allen. No. Still too fast? Let's see. Come on. Come on, man. Yeah, it is too fast. Why? Why is it too fast? This isn't the optimal way to solve any problem, but it will show me if that is the correct problem. Oh, still nothing. Oh, that's when you don't implement something correctly. This delta time. If you go back into this thing, and you go to our update, you will see it's 0. That means the player doesn't exist. The player's position, it knows everything. So it's not even, yeah, it's not great. Load delta time equal to game time, not get lapse game time. So this is the amount of time that passed since the last time the game updated. Let's see. Oh, well, before I forget, just say here, delta time. Oh, it's just going to show the exact same thing. Let's see. Well, something is still incorrect. At this point, just say 0. Add nothing to it every frame. Add 0 to it every single frame. Still doesn't exist. Why? Why doesn't it exist? Body. Let's just remove this entirely to check if this is our problem. I think this is our problem. Yes. The Verlet transform is implemented incorrectly. Implemented correctly. Just say that in English and not in gibberish. Yes. 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 Now what's your problem? I shouldn't have. No, I think that will fix it. But we'll have to see. Maybe, see, nothing's fixed yet. Maybe it's because we implemented this incorrectly. Position. Okay, got that. It is a class, so it is passed by reference. Whatever it's, if it is modified, it would reflect the modification. Let's see, draw code. Create a sprite, begin, drawing, each component sprite. DE. Yes, I want to do that. That too. That is very interesting. Interesting. It's just not working. But why? Probably my fault. Computer is only as smart as it tell it to be. As smart as the person programming it. In this case, me. Let's see. Delta time, yes. Okay, go back to the previous implementation again. The file location. Physics system. Correct. Correct. Of that. All of this is correct. But something is not. Let's see. Maybe I didn't get out of time correctly. Let's see here, space game. And that is irony. Doing 10. See here, time fox. Game time, total. Oh, total seconds. Milliseconds will have it update too much. Hopefully that's the case. Million different solutions, and that is not the solution. You think here. Oh. The problem with Verlet integration is it needs initial conditions. In other words, the position and old position already need to be set to something. And we didn't set old position. So that means position minus old position minus null. So it can give us either 0 or infinity. That is some range, isn't it? It's just, for the sake of simplicity, just rename this again. Position. There you go. Lightbox. Now, if I predict this correctly, it will stand still and it will work. There we go. We fixed millions of problems and only one was the solution. There you go. Okay, play system. Now I can apply force to test if this works correctly. Make it move to the right. Come on, please. Please do what I tell you to do. Now, if you look carefully, I did this in the Y, so it's not going to move right, it's going to move downwards. It moves. So that means it's correct. The only other problem, this is more other thing, is this ratio. This is so that if you run on different refresh rates, you get the same thing. So if I run this on a very good gaming rig and on my potato PC, it will have the same nice performance and physics. That means we actually need the refresh rate. There are ways of doing this better, but for the sake of simplicity, again, we will just define the refresh rate. So I'll just say here, public constant refresh rate. So this is a constant, capitals. And we go into rigid body system and we times this by that refresh rate. Folks, the expected refresh rate. Go. And it's moving rather quickly. There you go. Now, so that I don't forget, make the refresh rate dynamic. So we can test what the refresh rate is. We'll probably, the other way you can do this, which I will probably do, rather than actually testing what the current refresh rate is by having the user choose what they want their refresh rate to be. That will be another solution. But this is a simple game, just to show how an entity component system works in Monogame. So we're not going to implement that. We're not going to waste our time. So let's go back and fix the artifact that we previously had. I think it's this. We're calling this twice. Sprite.begin. Just take this and paste it. Now we will see. This might just ruin the game, yeah. Okay. Rubber duck method. Set in the target. That's the texture we want to draw to, so that we can scale it. Okay. This, draw it to that texture. And begin. And end. Okay, what's this? Mapping. I think it's the order. We need to put this down just to make sure. Yes. Okay, that kills it. That's not what we want. Shift end. Okay. Not that either. Back we go. In most cases, Google is your friend. But with Monogame, sometimes Google is not your friend. Just go look at how you did it years ago. Let me find it. I think it would be in this file. Let's see. Draw, clear, menu manager. This is not great code. Never go back and expect to see good code. See? Go down, down, down. You see this is pretty bad code. Draw, current menu, draw. Now I need to navigate to the current menu. Okay. Main menu. Let's see. Maybe I didn't even implement it. Yeah, I think I didn't do the scaling at all. That is also probably true. See? Okay. Yes. Load content, update your. Nothing. Oh, this is not a solution. Not a solution at all. My last try, otherwise I'm going to remove this entirely. It's not currently necessary for a simple game. Let's see. Oh, we have something here. Not really what we like, but okay. For the sake of simplicity, we will just kill this idea. There goes 1 hour of work. I think that was a previous live stream. No, it's teeny tiny, look at that. It's going even, it's accelerating. There it goes, woo! Let us see. It's just okay. Let's refactor some code to add a new folder. This will be systems folder. And we will put everything, every system in there. Yes, we will have a lot, a ton of them. Yes. And our new system will be a sprite system. It will draw all our good old things. See someone leave the like. Thank you. If any questions, just ask in the chat. I'm waiting. I'm waiting. ECA system. Show. Yes. Because maybe the stream is quite dry because I don't interact much. But it's okay. Just talk to me and I'll talk back. I'll do what parents hate. I'll talk back. Registry. This is not a good idea. Don't want it an update. Row, not new, not implemented exception. We want it in draw. How are we? Maybe, is it even a good idea to implement it and remove it from? That's another tip. Think before you do something. Because there's no problem with this. Maybe there is. let's just remove it. Registry. Fix that. No errors. That's what we want. We want to get all the sprites from the registry. So, put in sprite. That's it. And now for each sprite or entity, we're just going to call this S in the view, in our collection we just made. We want to get the sprite is equals C view dot registry dot get component. We want the sprite S. Oh, whoops. Let's just call this E again. Go back and say S.show is no. You see, that's where the problem is again. That's why I wanted to keep it, because then I have to pass the sprite badge as well. That can be a bit stupid, rather than just throwing it all in here. Yeah, let's just leave it as is, so we can just get to the actual physics. What's wrong here? Player system cannot be found. Why not? Let's see here. Oh, using fox.systems. Now it can be found. Yes, now it can be found. Okay. So let's implement physics. In the rigid body class, I want to apply constraints so it cannot go outside of the map. Create a good or private method. Apply constraints. Won't need anything. This will just check if the position at X is greater than the line fox dot map width, and we will just reset the position equal to line fox dot map width. There we go. Just create map width, otherwise we don't have anything to compare with. Map width, let's just say 800, and map height will be 600. This needs to be static. It can be accessed from everywhere. It's a problem. Constant cannot be marked as static. And now, no, okay, whatever. Read only. Solutions, people. Upgrades. Now, push the body system. Now we can just apply. It's inaccessible. What do you mean? Oh, public. Now it is accessible to everyone, everywhere. Otherwise, if the position X Maybe I don't even, yeah, we can just make this even simpler. Think about it. If the position is greater than the map width, or the position of x is greater than, smaller than 0, we will reset it to the old position of x. Now do the same thing with y. Something everybody asks, everybody. And we want map height. There you go. Apply constraints. Apply constraints. Yeah. Now just to quicken everything, see if this actually works. We'll just add a great force to it. There we go. And it fell right through. Not good. Not good. This is old position. Okay. We can just do all this before we create, we set the old position equal to the new position. Let's see here. Now it is too slow. Okay, fair enough. We will not use old position. Fox. Copy this. Yes, it will be exactly the same type of code, just like that. I just switch it around because we don't want it smaller than 0. We're fine if it is bigger than 0. Make this an else. Copy and paste this. Yes, it will be the same code for y, just different variables. Map height, if it is greater than map height. If y is bigger than map height, we want it equal to map height. No problem. If you do what I just did, by resetting it back to map height, you will lose the magnitude of the vector, some of it. So, for example, if I throw all against this wall with, let's say, a force that big, then we want it to reflect exactly the same way. If we add, let's say, an elastic collision, like in high school, it keeps its kinetic energy. In other words, elastic collision, you don't even need this sum. Disappear sum. Like that. If the kinetic energy, come on. Why doesn't this? Come on, pick this. Pick black. Yeah, there we go. If the kinetic energy, initial kinetic energy, is equal to final kinetic energy, we have an elastic collision. So that is essentially, this happens. A perfect reflection. Just pretend it's perfect because it's not. But since we're changing velocity based on position, when the ball goes outside here and we put it here, we lose some of that velocity. So let's say it was this big, now it's this small. For now, this is not a problem. This might later on become a problem. And for the system we're designing this, it doesn't really matter. But just keep this in mind if you want to put in Verlet transforms or integration in your game. So just remember this. Let me just put here to do. Perfect the reflection. I can say it like that. Now let's run this. Check it if it is working. That's what you have to do for every single project. There it goes. And it went right through. This is probably because the screen is smaller than the map height. Yes, see here. Yeah. Width, we would like 800 and we would like this to be 600. Now the ball might be too small to see. Let's see. Maybe it is too small. It still didn't work. But did we switch this around? Okay. So what we learned is do not apply constraints in here. We just remove this. Make this public and do it every single time after we update the object. rb.apply constraints. Okay. It's going down and it still didn't work. Why didn't it work? Let's see. Apply constraints. No, it's just. Yeah, wait. It's 800, 600. Behind 600. Okay. Why don't you want to work? Tell me why. Let's see if it's something to do with the component, the actual position component. Okay, we know that. We know that. Yes. Okay. Body, my constraints. Let's make this smaller. Maybe it's just size too large or something. Oh, there it does something. That is correct. But I still think this should be, apply constraints should not be there. Not be in the update method. Should be here. Not here. But let's see if the computer agrees with me. No, it still works. Well, okay. What if we made this larger? Let's see. Now this finger is going to be speedy. It stops exactly there. It should stop there. Okay, that is correct. So we have a little box for it. Let's just reset everything back. Let's just make this 600 and 400. And the same here. So that this is going right through the display. Not what we want. See, here's where the advantage of the entity components come in. If we want to debug something, we can just add it in the component code. So then we can view what's happening. Let's see that stream is buffering. Doesn't matter. Hopefully you like my lovely voice and prefer to stick around. We want to see what the position is. And we want to see it clearly, so we're just going to say debug.writeLine. Now it should appear here, 50, 50, 50. Still 50. Oh, we're writing the wrong variable. We want y. Because it's falling down due to gravity. Or whatever you'd like it to be. Not really gravity. There we go. So now it's just 400, 0, 1, 6, 7. That is because we're adding it every single frame. Okay, that makes sense. Okay, so the issue is, let me just clear the drawing board again. I've realized the issue is not the actual join code. It is the join code. When the position, each object's position is in the top left corner in Monogame. So we check if that top left corner is greater than the map height. So when it is equal to or greater than, like there, this is our screen. And this is what we can view, everything inside this box. So we can't view the object when it is equal to map height, because the actual position is in the left corner, top left corner. So in this case, we won't see it at all, but it works, it's still correct. So let's just fix it. Fix it, Phoenix. There are many ways you can just use the center or actually calculate how large the object is with a heat box or something. But we want a lazy solution, a lazy and quick solution. That will be to make the velocity a class variable so that we can use it. And every time it is something like this, we will, let's just put that back. We want to do that still, but we want to be extra. We will just invert the velocity, so it will bounce around. Let's check. This should work. If it doesn't, I'm not sure. It's just my physics being a bit rusty. Copy, paste. It will be the same for all dimensions, just different values. Okay. See, that is where we can make a mistake. We don't want the entire velocity to be negated when we just want x to be negated. For now. Go. Y. And y. I'll make this, yeah, this should be 0. This should be map height. So if it is greater than map height, we want it equal to map height and reflect velocity, so that it will go back in the same direction. Let's see if this works. Just don't mind this. Where is it? It's not working. Okay. Why aren't you working? Let's see, velocity. Yeah, we know that. Let's just say -10. Lazy solution again. -10 everywhere. No, wait. We wrote a thing to improve this. We don't want to change the velocity. I'm completely wrong. We want to apply a force. Apply a force. In this case, we want it. What about just equal to velocity? No. Okay. This will not work. It will be quite too much thinking, too much maths for something that is temporary. Better solution is just to create a box. But that is a later problem. But for now, basics I have to implement it. Let's just, what we can do is we can just make it the center so that we can see it for the last time. We see flying fox. So there we go. Zero origin. The origin will be the position. That's the center. Scale 1. Sprite effects none. Layered none. Okay, let's check. There you go. Probably work. Hopefully. See. Now something is happening here. Since we're spawning it in the top left corner, it isn't even moving down. We're just resetting it the entire time. So we'll transfer. Yes, indeed. Okay, that's not correct. This is completely correct. Okay, it's 8 by 8. So we'll just make a new T2 4 by 4. Center of the texture. Let's check now. Now it's working. I have no idea how I did that, but I do not mind. I think I switched the code around. Let's see. Yeah, easy. Firefox. But for today, that's fine. Now, I want to say thank you for tuning in. Hopefully now you can also implement your own Verlet integration in your game. I hope you enjoyed it. Have a lovely